Picture a universe so young that not even stars had been born. In this primordial chaos, something extraordinary may have emerged. Black holes as ancient as time itself. And here's the most intriguing part. They might hold the key to unlocking one of modern science's greatest mysteries, dark matter. In the first moments after the birth of our cosmos, when the universe was nothing more than a soup of fundamental particles and raw energy, these cosmic titans began to form. We call them primordial black holes, and they're unlike anything else we've discovered in our cosmic neighborhood. They weren't born from dying stars or colliding galaxies. They emerged from the very fabric of space and time itself. Think about that for a moment. While we typically imagine black holes as the dramatic endings of massive stars, these ancient behemoths were here before the first star ever shone its light. They're like cosmic fossils, preserving secrets from the universe's earliest moments, waiting for us to decode their message. Today, we're embarking on an extraordinary journey through space and time. We'll dive deep into quantum gravity, a theory that attempts to explain how these cosmic monsters could have formed in the universe's first breath. We'll explore why these ancient black holes might be the perfect candidates to explain the mysterious dark matter that holds our galaxies together. In this video, we'll venture into the quantum realm of gravity, understand how these primordial black holes could have formed in the universe's first moments, and discover why scientists are so excited about their potential role in solving the dark matter puzzle. Get ready to challenge everything you thought you knew about the cosmos. Welcome to Exploring the Universe, where we unravel the greatest mysteries of space. If you're fascinated by the secrets of our universe, make sure to subscribe to our channel and join us on this cosmic adventure. Hit that like button if you're ready to explore one of the most mind-bending concepts in modern astronomy. Let's dive into one of physics' most fascinating puzzles, quantum gravity. You know, it's quite remarkable. We have two incredible theories that explain almost everything in our universe, but they just won't talk to each other. On one side, we have Einstein's general relativity, his masterpiece that describes gravity as the curvature of space and time itself. On the other, we have quantum mechanics, which explains how the tiniest particles in our universe behave. Here's the thing that keeps physicists up at night. These two theories work brilliantly in their own realms, but when we try to make them work together, especially in extreme conditions like inside black holes or at the beginning of the universe, they clash spectacularly. It's like having two pieces of a puzzle that look like they should fit perfectly, but somehow don't quite match up. This is where quantum gravity comes in. It's our attempt to bridge this gap, to find the missing link between these two fundamental theories. Imagine trying to describe gravity not as a smooth, continuous force as Einstein did, but as something that comes in tiny, discrete packets, just like light comes in photons. What's truly mind-bending is that quantum gravity might finally help us peek inside black holes. You see, at the heart of every black hole lies something called a singularity, a point where our current physics simply breaks down. It's like hitting a mathematical wall where all our equations throw up their hands and give up. Quantum gravity might finally give us the tools to understand what's really happening in there. Here's something to wrap your mind around. If gravity does come in particles, what would these gravity particles look like? Scientists have already given them a name, gravitons, but no one has ever seen one. They would be the force carriers of gravity, just like photons carry light. But detecting a graviton would be incredibly challenging. They would interact with matter even more weakly than neutrinos, those ghostly particles that can pass through entire planets without stopping. This is where I'd love to hear your thoughts. What do you imagine a particle of gravity would look like? How would it behave? What color would it be, if it could have a color? Share your creative theories in the comments below. Sometimes the most remarkable scientific discoveries start with a simple act of imagination. Remember, we're not just talking about abstract physics here. Understanding quantum gravity could revolutionize our technology, our energy systems, and our understanding of the universe itself. Who knows? Maybe one of you watching right now will be the one to finally crack this cosmic puzzle. Let's travel back to the very beginning of everything. And I mean everything. We're talking about the primordial universe, just moments after the Big Bang. If you could somehow survive there, you'd witness the most extreme conditions imaginable. The entire universe was packed into a space so incredibly hot and dense that it would make the center of today's stars look like a winter morning in comparison. In these first fractions of a second, our universe was a cosmic pressure cooker. The temperature was so extreme that not even atoms could form. We're talking about temperatures in the trillions and trillions of degrees. Everything we know, every galaxy, every star, every planet was just a soup of pure energy and fundamental particles swirling in this cosmic cauldron. But here's where things get really interesting. In this incredibly dense state, the quantum world was playing a fascinating game. You see, quantum mechanics tells us that at these tiny scales, reality isn't as solid as we think. The energy and matter in this early universe were fluctuating wildly, creating regions where the density would suddenly spike to extraordinary levels. Imagine throwing a stone into a perfectly calm pond. The ripples that form are similar to what was happening in the early universe, except these weren't ripples in water. They were ripples in the fabric of space-time itself. In some places, these ripples created areas so dense that they collapsed under their own gravity, forming what we now call primordial black holes. As Stephen Hawking beautifully put it, these primordial black holes are like fossils from the Big Bang. Just as paleontologists study dinosaur bones to understand Earth's past, astronomers study these ancient black holes to understand our cosmic origins. They're time capsules, preserving information about the universe when it was less than a second old. What's particularly fascinating is that these black holes didn't need stars to form. They were born directly from the chaos of creation, making them fundamentally different from the black holes we see forming today. They're like the firstborn children of our universe, emerging before even the first stars had a chance to shine. Think about that for a moment. Somewhere out there, possibly even in our own galaxy, these ancient cosmic titans are still lurking, carrying secrets about how our universe began. They've been there since the very beginning, silent witnesses to the entire history of our cosmos. These primordial black holes might be small, some possibly as tiny as a mountain, while others might be as massive as thousands of suns. But regardless of their size, they all share the same remarkable origin story, born in the first breath of our universe, when space and time themselves were just learning how to exist. Let's talk about primordial black holes. And trust me, these aren't your average cosmic monsters. While most black holes we know about form when massive stars die in spectacular explosions, these ancient ones are special. They're the universe's original black holes, formed before the first stars even existed. Think of them as the great-great-grandparents of all black holes. Recent studies have revealed something absolutely mind-blowing about these cosmic relics. Their size range is simply staggering. Some might be so tiny they're no heavier than a grain of sand, while others could be as massive as thousands of suns combined. This incredible variety makes them unique in the cosmic zoo. It's like finding out that dragons could be as small as hummingbirds or as large as entire continents. Here's something that will really make your head spin. These ancient black holes might be a lot closer to home than we think. Scientists believe they could be scattered throughout our own Milky Way galaxy, hiding in plain sight. But why haven't we seen them? Well, that's where things get even more interesting. Unlike their stellar cousins, which often announce their presence by devouring nearby stars in spectacular light shows, primordial black holes might be more subtle. The smaller ones could be practically invisible to our current technology, silently drifting through space like cosmic ghosts. Think about this. You might have a microscopic black hole passing through your neighborhood right now, and you'd never know it. Don't worry though. These tiny black holes would be too small to cause any harm. Their gravitational pull would only affect things in their immediate vicinity, at distances smaller than an atom. What makes these cosmic wanderers even more fascinating is their potential role in one of astronomy's biggest mysteries. They might be contributing significantly to the dark matter in our galaxy. Imagine millions or even billions of these invisible objects, ranging from microscopic to massive, all scattered throughout our galaxy like hidden weights, their gravity helping to hold everything together. The hunt for these elusive objects has become one of modern astronomy's most exciting quests. Scientists are using everything from gravitational wave detectors to advanced telescopes, hoping to catch glimpses of these ancient cosmic artifacts. Every time we detect a gravitational wave signal that doesn't quite match what we'd expect from regular black holes, we might be seeing evidence of these primordial giants. It's like we're cosmic detectives searching for the universe's firstborn children, and every new discovery brings us closer to understanding not just how black holes form, but how our entire universe came to be. Now, let's explore one of the most intriguing mysteries in modern astronomy: dark matter. Imagine there's something out there, something we can't see, that's holding entire galaxies together like an invisible cosmic glue. That's dark matter. And here's where our story gets really interesting. When astronomers look at how galaxies move, they notice something peculiar. These massive collections of stars are spinning so fast that they should literally tear themselves apart. But they don't. It's as if some invisible hand is holding everything together. That's where dark matter comes in. We can't see it, but we can definitely feel its gravitational effects. This is where primordial black holes enter the picture, and they might just be the perfect candidates for dark matter. Think about it. They're invisible, they were created at the beginning of time, and they have powerful gravitational effects. It's like finding out that the ghost you've been trying to catch has been hiding in plain sight all along. Right now, we're in the middle of an exciting cosmic treasure hunt. The Hubble Space Telescope is searching the depths of space for subtle signs of these ancient black holes. Meanwhile, LIGO, our gravitational wave detector, is listening for the subtle ripples in space-time that might be caused by primordial black holes colliding with each other. It's like we're both looking and listening for these elusive cosmic objects. But here's a question that often comes up. If these primordial black holes are really out there, why haven't we spotted them yet? Well, imagine trying to find a black marble in the ocean at night. Many of these black holes might be incredibly small, some barely bigger than an atom. They're still massive enough to contribute to the dark matter puzzle, but too small to give off the kind of radiation we can easily detect with our current technology. Some of these ancient black holes might be passing through our solar system right now, but they're so tiny and moving so fast that we'd never notice them. They're like cosmic ninjas, invisible but incredibly powerful. The data we're gathering is painting an increasingly interesting picture. Every gravitational wave detection, every unexplained gravitational lensing event could be another piece of evidence pointing toward these primordial black holes as the source of dark matter. What do you think about this cosmic mystery? Could these ancient black holes really be the dark matter we've been searching for all this time? Share your thoughts in the comments below. Are you as fascinated by this possibility as astronomers are? Do you think we might be on the verge of solving one of the universe's biggest mysteries? If you're enjoying this journey through the cosmos, don't forget to hit that like button and subscribe to Exploring the Universe. We're just getting started with unraveling the mysteries of our universe, and you won't want to miss what's coming next. The hunt for primordial black holes has sparked a technological revolution in astronomy. We're using some of the most sophisticated instruments ever built by humanity, creating what I like to call our cosmic detective toolkit. Let me take you through this amazing array of scientific instruments that are helping us search for these ancient cosmic mysteries. First up are our gamma-ray telescopes, incredible machines that can detect the most energetic light in the universe. These telescopes are looking for tiny flashes of radiation that might occur when primordial black holes expire. You see, Stephen Hawking predicted that black holes actually evaporate over time, and the smaller ones might be doing so right now, creating brief but powerful bursts of gamma radiation. Then we have our gravitational wave detectors like LIGO, which are perhaps the most sensitive measuring devices ever created by humans. Imagine being able to detect a change in distance smaller than the width of an atom between mirrors separated by several kilometers. These incredible machines are listening for the ripples in space-time caused when primordial black holes collide. It's like hearing the echo of the universe's first moments. But some of our most powerful tools aren't physical instruments at all. They're computer simulations. Modern supercomputers are creating incredibly detailed models of how primordial black holes might have formed and evolved throughout cosmic history. These virtual universes help us understand what to look for in the real one. Scientists can run millions of scenarios, each one helping us narrow down where and how we might find these elusive objects. Here's something exciting. The James Webb Space Telescope, humanity's most powerful eye in the sky, might help us in this search too. While it can't see primordial black holes directly, it can observe their effects on surrounding matter and light. It's like tracking an invisible animal by looking for its footprints in the cosmic snow. The Webb telescope can peer so far back in time that it might catch glimpses of the earliest effects these primordial black holes had on the forming universe. If we do confirm the existence of primordial black holes, it would be nothing short of revolutionary. Think about it. We would not only solve the dark matter mystery, but also gain direct evidence from the universe's first fraction of a second. It would be like finding a time capsule from the Big Bang itself. This discovery would force us to rewrite our understanding of how the universe evolved, and might even give us new insights into the nature of space, time, and gravity itself. Every day, these instruments are collecting more data, and every piece of information brings us closer to potentially making this groundbreaking discovery. We're living in an age where science fiction is becoming science fact, where the tools we've created are allowing us to probe the deepest mysteries of creation itself. And who knows? Maybe as you're watching this video, one of these instruments is picking up the first definitive signal of a primordial black hole, getting ready to change our understanding of the cosmos forever. As we look toward the future of this cosmic investigation, the possibilities are truly mind-bending. Data from our most advanced telescopes and detectors is painting an increasingly intriguing picture. If primordial black holes are confirmed to exist, we might be on the verge of solving not just one, but several of the universe's most perplexing mysteries. Think about this. These ancient cosmic titans might explain how the first galaxies formed so quickly after the Big Bang. Current models struggle to explain how such massive structures could have assembled so fast, but primordial black holes might have acted like cosmic seeds, their powerful gravity drawing matter together and kick-starting galaxy formation much earlier than we thought possible. The implications go even further. These primordial black holes might help us understand why galaxies appear to be distributed in a vast cosmic web across space. Imagine a network of these ancient black holes formed in the universe's first moments, creating a gravitational framework around which the entire visible cosmos has been built. Neil deGrasse Tyson put it brilliantly when he said that primordial black holes might be the missing piece of the cosmic puzzle. And he's right. These objects could be the key that unlocks multiple doors in our understanding of the universe. They might explain not only dark matter, but also help us understand the nature of gravity itself. Here's something fascinating to consider. What if dark matter isn't just a uniform, invisible substance spreading throughout space? What if it's actually a complex network of primordial black holes connected through their gravitational influence, forming an invisible skeleton that holds our universe together. This idea isn't just science fiction anymore. It's a serious scientific possibility that researchers are actively investigating. Recent gravitational wave observations have detected black hole mergers that seem unusually heavy or light compared to what we'd expect from stellar black holes. Could these be our first glimpses of primordial black holes colliding? The next decade of observations might finally give us the answer. As we develop more sensitive instruments and gather more data, we're getting closer to either confirming or ruling out these fascinating possibilities. The Large Synoptic Survey Telescope, currently under construction, will scan the entire visible sky every few nights, looking for subtle gravitational lensing effects that might reveal the presence of these ancient cosmic objects. Moreover, as quantum gravity theories continue to evolve, we might soon have a complete mathematical framework that explains exactly how these primordial black holes formed in the universe's first moments. This would be more than just another scientific discovery. It would be a window into the very birth of our cosmos. The next few years promise to be incredibly exciting for this field of research. We might be standing on the brink of a revolutionary discovery that changes everything we thought we knew about the universe. And the best part, we're all here to witness it happen. The universe has kept this secret for nearly 14 billion years. But with our growing understanding and technological capabilities, we might finally be ready to uncover the truth about these mysterious objects that could have been hiding in plain sight since the very beginning of time itself. Now, let me share something absolutely mind-blowing with you. We've been talking about primordial black holes throughout this journey, but here's where everything comes together in the most spectacular way. Think about it. If primordial black holes really exist, they wouldn't just solve the dark matter mystery. They would completely transform our understanding of the entire universe. It would be like finally finding the missing piece of a cosmic puzzle we've been trying to solve for over a century. These ancient cosmic titans could be the smoking gun, the evidence we've been searching for to prove that quantum gravity is real. And the most incredible part, this evidence has been hiding in plain sight all along, lurking in the shadows of our cosmos, patiently waiting for us to notice it. Imagine discovering that the universe is far stranger and more wonderful than we ever dared to imagine. It would be like learning that magic is real, except this magic follows the precise rules of quantum physics. These primordial black holes could be like cosmic magicians, performing tricks with space and time that seem to defy our classical understanding of gravity. When Albert Einstein first proposed his theory of general relativity in 1915, he probably never imagined that the ultimate proof of quantum gravity might come from these ancient cosmic objects. It's like the universe has been playing a cosmic game of hide and seek with us, and we're finally getting close to yelling, "Found you!" The implications are staggering. If we confirm the existence of primordial black holes, it would mean that quantum effects were powerful enough to punch holes in the fabric of space-time itself during the universe's first moments. It would be the ultimate vindication of quantum gravity theories, proving that even gravity, the force that shapes our cosmos on the grandest scales, follows quantum rules at its heart. But perhaps the most beautiful part of this revelation is how it shows us that the universe is more interconnected than we ever imagined. From the smallest quantum fluctuations in the beginning of time to the largest structures we see today, everything might be linked through these primordial black holes. They're like the universe's original architects, their invisible hands helping to shape everything we see around us. And here's a thought that keeps me up at night. What if we're just scratching the surface? What if primordial black holes are just the first of many cosmic secrets waiting to be discovered? The universe might be even stranger and more wonderful than we can possibly imagine, and we're living in the exciting time when these mysteries are finally being unveiled. This isn't just another scientific discovery. This is potentially the key to understanding the very nature of space, time, and gravity itself. We might be standing on the brink of the greatest revolution in physics since Einstein's theories changed our view of the cosmos. And the best part? We're all here to witness it happen. As we reach the end of our cosmic journey today, let's take a moment to reflect on the extraordinary ideas we've explored together. We've ventured into some of the most profound mysteries of our universe, and what we've discovered is nothing short of amazing. We've learned how quantum gravity, this elegant dance between Einstein's relativity and the quantum world, might explain how the universe created its first black holes. These weren't born from dying stars, but from the very fabric of space-time itself, in the universe's earliest moments. It's like discovering that the universe knew how to create black holes before it even knew how to make stars. These primordial black holes might be the key to solving one of the greatest cosmic mysteries of our time: dark matter. For decades, scientists have been searching for this invisible substance that seems to hold our galaxies together. And now, wouldn't it be extraordinary if the answer has been hiding in these ancient cosmic relics all along? It's like finding out that the treasure you've been searching for across the world was actually in your own backyard. Modern technology is bringing us closer than ever to confirming these incredible theories. From the powerful James Webb Space Telescope to the incredibly sensitive gravitational wave detectors, we're developing tools that would have seemed like science fiction just a few decades ago. Each new instrument brings us closer to understanding these cosmic mysteries, like pieces of a grand puzzle finally coming together. You know, when I think about where we are in this journey of discovery, I'm reminded of what Carl Sagan once said: somewhere, something incredible is waiting to be known, and we might be on the verge of proving him right once again. The next few years could bring discoveries that will fundamentally change our understanding of the cosmos. But this journey isn't just about black holes, dark matter, or quantum gravity. It's about us, human beings, pushing the boundaries of knowledge, daring to ask the biggest questions about our universe. It's about our endless curiosity and determination to understand our place in this vast cosmic ocean. Before we part ways today, I want to thank you for joining me on this incredible exploration of the universe. If you've enjoyed this journey through the cosmos as much as I have, make sure to subscribe to Exploring the Universe. Hit that notification bell to stay updated with more fascinating content about our universe. Give this video a like if you've learned something new today, and share it with your friends who love to ponder the mysteries of the cosmos as much as we do. Remember, every time you look up at the night sky, you're not just seeing stars and galaxies, you're seeing mysteries waiting to be solved, questions waiting to be answered, and who knows, maybe you'll be the one to help unlock the next great secret of the universe. Until next time, keep looking up, keep asking questions, and keep exploring the universe. Because in the end, we're all cosmic explorers, trying to understand this amazing universe we call home.